Hey guys, welcome back to my series on building an end-to-end machine learning pipeline. In the last two lessons, we have discussed about model training, monitoring, inference, and ONNX packaging. In this lesson, we will be talking about Docker and FastAPI. So before deploying our model into production environment, we need to build and test it locally. So in order to do this, we'll be using FastAPI. So there will be four main steps that we are going to discuss in these lessons. The first step is to create a FastAPI app. Second step is to build a Docker image. Third step is to run it locally. And last step is to share your Docker image. Now let me go to Visual Studio Code and we will start by opening the folder for this lesson. Let me open a new terminal here. First, let's change the directory to this lesson folder. The first step is to install FastAPI. So through this, you will key in install, pip install FastAPI. I already installed it on my computer, and you will also need to install UVCon to run FastAPI. So once you have installed these two, now we are ready to create a web page for FastAPI. And you will need to create a Python file called app.pipe. So here I already have it. Let me go through the steps here. Let's first create a basic web page, FastAPI web page. Let me comment out this one. Okay, I think it's better if I close this camera. So here in this web page, we have quite a lot of import here, but for the time being, none of these are needed. Here you just need to focus on two lines. These first is app. App here is a FastAPI app with the title. This is the title of the web page, MLOps emotion recognition. And on this web page, we have the home page, which is just a sample prediction API. In order to run this, we will use UVCon. The command is a bit long to type out, so let me go to my blog post. So we can run it by this command. In this command here, UVCon app:app, the first app here is the FastAPI app that we created in this line. The second app here is the file app.pipe, right? And we're running it on a local host. Here we also have the tag reload. This means every time we make change to app.pipe, the page will be automatically reloaded. We don't need to run it again. We just need to change the app.pipe, and then the page will be automatically reloaded. Well, it looks like there is a typo in this command. First, we need we need to put them nearby. So let's run it again. Right now we can see that UVCon is running on this local host, and we can go here to check it out. So this is the web page. To have an interactive reading of the web page, you need to go into the docs side, and here is the web page. Right now there is nothing going on. We just have the title of the page and the home page, which basically have nothing. Next, we are going to integrate our emotion predictor into this FastAPI web page. So let me go back to VS Code. To make the app take in input image and produce prediction, we need to create an API. So we call this API predict, and we will define the method get prediction in this API. So this is where I comment out in the beginning. So let's look at this API predict here, in which we define the function get predictions. This function has 3 optional arguments: image path, video path, and camera index. So all these paths are the local paths in your computer. If we key in an image path, then we will read the image, right, and then get the result using the emotion predictor. Well, let me recall a little about the emotion predictor that we discussed in the last lessons. So this is from Inference ONNX. Right, it's Inference ONNX. So this emotion predictor class is a class that is used to process the input image if we happen to put in an input image, or input video, or camera webcam. So in this case, if we key in an image path, then we will get the result, and we will show the result by streaming it on the website. So to do that, we need to create an image stream and then stream it on the FastAPI website. For the case of video path, I guess there should be some similar way to do it, but here I don't want to spend too much time, so I just process it and return the process path of the video. So what happened here is the result video path will be returned and displayed on the FastAPI website. Well, in the case of camera index, I still don't know how to describe this interactively on the website. So basically this, I guess this doesn't work. I've tried it out and it doesn't work. So now, recall that I mentioned that whenever we make change to this app.py file, the FastAPI website will be automatically reloaded. So here we just hit reload, and we can see the change is already here. We get the predict API, and in this predict API we have 3 commands, right? So let's try it out. So let's put in an image path. Let me see. I have an image here. So you need to key in the path of this image in your local computer. Not sure if I need double quote. I think I need. And hit execute. Image not found. Perhaps I don't need the double quote because this is already in the string format. Let's try it again. Yeah, it's running. So now you can see the result. Yeah, it display the emotion of the people who are in these pictures. Yeah, I guess pretty good. Well, so that is how we can test our emotion predictor using FastAPI and run it interactively on a website. The next step will be to build a Docker image and run that Docker image. First, why do we need to have a Docker image? Basically, what I am doing here might not run on your systems. I'm running the Apple system, and my code might not be running on your Windows system, for example. So Docker is a tool that packages everything in my code into a portable image. So this image can be shared and run consistently across different platforms and systems. Let me go to my blog post just to explain a little about Docker. There are 3 main components in Docker. First is Docker file, second is Docker image, and the third one is Docker container. A Docker file is a simple text file that contains a list of instructions to build a Docker image. A Docker image is an executable package created by Dockerfile, right? And it includes everything that is needed to run the application. A Docker container is a running instance of the Docker image. So here, in summary, Docker file define the setup, Docker image package the application, and Docker container run the application. Let us start with Docker file. Let me go back to VS Code here, and we will look at the Docker file. So here is the Docker file. In this Docker file, there are a few components here. We start from the base image, which is Python 3.11, and we have a few run commands. The first one here is to install library for OpenCV. The second one is to create a working directory inside the Docker image, and the main working directory inside the Docker image is app. The third one is just install some build tools. The next one here is important, that is to install the dependency which are inside a text file requirements.txt. So first we will need to copy this file here, requirement.txt, into the working directory and then install it. And here is the text file. So the question here is, how do we determine which requirements are needed? So to determine which requirements are needed, we need to go to the app.py file, and basically we need to install all the requirements that appear in this app.py, because at the end we are going to run this file. So looking at this app.py file, we have OpenCV, right? We have FastAPI, and then we need everything that is needed to run emotion predictor. So for this, we need to go back to inference ONNX, and here we need Unix runtime, logging, we need touch vision, touch face recognition, and NumPy. So for that, I have written out all these package that will be needed in order to run app.py. So all these are the requirements that are required to run before we can run app.py. So here we will run the requirement by this command, and then we copy the rest of the application file into the working folder app. So that means we copy everything here into app, and then we run the application by uvcon app:app. The first app here is the folder that we created, which is this one. The second app is the Python 5 app.py. We run it on localhost. Right? So now we are ready to build a Docker image. Let me open up the terminal. Well, I need to change to this current working directory. We can before we build Docker, we need to make sure that it is currently being run, and you will need to download Docker Desktop. You need to install Docker Desktop if you haven't done so. So on the search bar, you should search for Docker Desktop and install it if you haven't done so. Right? So here you can install Docker Desktop from here. To run, just type in the file Docker, and here I'm already running Docker Desktop. And now let's go back to VS Code, because we can only build Docker when it's running, so that's why we need to run it first. We will run Docker build, and we will tag our Docker image as inference latest, and we will run it in the current working directory. So we end with a dot here. Yeah, so now it's being run, and so if you run it successfully, it should look like this. So here you can see the step it is running. First it starts from the base image, and it run all the requirement. You can check the Docker image that you built by typing in Docker image, and here you can see the one that I built was just 22 seconds ago. So this is the Docker image I just built. Well, now we are ready to run an instance of the Docker image that we built. In other words, we will create a Docker container. In order to create a Docker container, we will use docker run. So this is a running instance of the image. We run it from the localhost, and let's name it inference emotion. Well, just emotion recognition. We run the Docker image inference latest. Now let's go to this localhost address to check out the result. Let's open it here. I'll go to the doc side. So here we basically have the same thing as before, everything as before. Let's try out by putting an image. So note that when I create the Docker image, one of the things that I do is I copy everything from the current folder to app. That means I copy everything in lesson 3 here to app, which include this image. So now in order to test on this image, I don't need to key in the whole path from my local computer to the FastAPI website. I simply need to key in the name of this image. So let me try it out. Yeah, you can see things work as before. So keep in mind that I am running the Docker image. So this is different from before where I run the app from my computer. If you had key in a path to an image to your local computer, it wouldn't work. The reason is because we are running in Docker container. We are running the Docker image, so everything needs to be pulled from the Docker image. If you key in an image which is not present in the Docker image, then you cannot run this function. So this make our application quite limited, right? So now we will try to address this problem by creating the predict function which can read an image URL and then give prediction based on the image URL, and that will be much better because now we are not restricted to reading only the image or video that are stored in the Docker image. So in order to do so, we will need to make change to this function app.py. Now the input will no longer be the image path but the image URL. So I will comment out these things here and make change to it. Well, let me go to lesson 4. So this is what I did in lesson 4. In this API, I have it receiving the URL as the argument, but to do this I also need to import request and numpy. So let me check the import here. Yeah, let's just copy this whole thing basically comment this out. All right. So now let's look at this predict API. So for this case, now the prediction function here will receive an URL. Here I only write image URL. So we will first load the content of the image into a NumPy array, read the image using OpenCV, and then get the predictions. Once we get the prediction, we do the same as before. We will stream the image prediction, the result image on the website. So here I only do it for the case of image URL. If you have video or camera, then I haven't really spent time into looking into this on how to show the video or camera in the FastAPI app. If you know how to do it, please share with me. Well, let me just interrupt this. Now, in order to adapt the change, we will need to build Docker again. Right? Need to run Docker build again because now our app.py is different. Well, let me just go to the command for Docker build from my website. So when you run Docker build, make sure you are in the current folder. So Docker build. All right. Well, let me check the Docker file that I have here. All right. Yeah, this was quite fast because what we change is the command where we run. The only thing that we change is the app.py 5. And now let's run Docker. So, well, to save time, this is the command for running Docker. No module name request. Okay, so what happened just now is we need request to run app.pipe, right? So this need to be included as one of the requirements. So yeah, there's no way, but we need to build Docker again. This will take some time, especially when running dlib. So I will pause the video here and I will come back when the build is finished. First, let me check the new Docker image. So here we can see this is the latest one, which was built just now. And let's run it as before. So we use the same command. Yeah, this container name inference is already in use, which we run before. So we have to remove yeah, let's just rename it inference emotion. So let's go to this localhost and test it out. So now we can see now the parameters is changed to image URL, video URL, or camera URL. Let's key in an URL of a testing image. So here I should have provided a testing URL. So this is the image that I give to test. Let's view it first. So this is the image, and we will key in the URL here, click execute. Yeah, and you can see now it works as before, right? Now it's much better because we don't need to, we can test on any image that is in the form of an URL. Before we are only restricted to testing the image in our local computer. That is the difference. Well, so we have finished the third step, which is to run the Docker container. And the last step in this lesson will be to share the Docker image. As you have seen, well, here the list. Let me stop this first. If you look at the Docker image that was built, they are usually in very large size. In this case, it's about 2.7 gigabytes. So storing it locally or sharing it directly with others can be inconvenient, right? Fortunately, we can push this to a central repository like Docker Hub, and by doing this, we can pull it down whenever we need. So to do this, first you will need to create a Docker Hub account. Well, just type in Docker Hub, go to this website, create an account if you don't have one. So here I already have one, and create an account. Once you create an account, then you will see click to repositories here, and then let's create a new repository, emotion Docker image. Click create, and here is a command to push to this repository. So in order to push to Docker Hub, there will be 3 steps. First, you need to log in from the terminal, and second, you need to tag the local image, and third, you will push it. So let me go through the step one by one. First, you can log in by key in Docker login. I already logged in before, so here you can see authenticating with existing credentials. If it is the first time you log in, you will be prompted to enter your Docker Hub username and password. So once we log in, we are going to tag the local image that we built just now with the repository name and desired tag. So let me go to this. This is the repository name and the tag that we want to name. So we will run docker tag. The image that we built just now is inference lattice, and let's tag it emotion docker image inference. Right, so after we tag it, now we can push it to Docker Hub, and this is the command to push to Docker Hub. We need to change tag name to inference. Yep, so that's it. Now the push is finished. You can go to Docker Hub, refresh, and then you can see the change. Now you can see this image was pushed to your repository. In order to pull this image, you simply run docker pull. So let me first check the Docker image that are currently in my computer. Right? So all these, well, let me just delete this, right? And then pull it down again. Well, to delete it, I will need to run docker remove. This says unable to delete the image because it is being run in, it is referenced in some repositories, which is the one we just push up. um, they say it must be Fox, so let's try to Fox remove it. Okay, look like it was removed. Let's run again. Yeah, you can see the image was removed. So now let's try to pull it from the Docker Hub. In order to pull it, we will run docker pull and run the docker pull on the image tag. Well, this should be inference. Well, pulling from this and look like it was finished. Let's check the Docker image again. Yeah, so you can see it was pulled out from the Docker Hub. And yeah, I'm not sure why this say it already exists. Perhaps it already exists in my Docker desktop, so it say already exists. I might need to delete it from my Docker desktop. You can try to pull it down and let me know whether it works. This is the end of this lesson. It took me quite a while to understand Docker and FastAPI. If you know any better practice or tips, I would love to hear from you. Thank you and see you next time.